In the year 1821, a hurricane struck New York City directly, drove a wall of seawater nearly 13 feet high into Manhattan, and flooded the island all the way to Canal Street. That storm is not history's curiosity. It is the city's blueprint for catastrophe. Scientists now say a modern version would put a quarter of New York underwater, parts of it under 20 feet. New York is spending more than $15 billion to stop it. In the next few minutes, I will show you why that money may not be enough, and what this means not just for 20 million New Yorkers, but for every American living on the coast. Welcome back to the Space Desk. Let's get into it. Here's the fact that almost nobody in New York City knows. The single most destructive storm scientists can imagine hitting the city, the one that floods a quarter of New York and puts entire neighborhoods under 20 feet of water, is not a forecast. It is not a worst-case projection pulled from a climate model. It is history. It has already happened. In the year 1821, a hurricane struck New York City directly, drove a wall of seawater nearly 13 feet high into Manhattan, and flooded the island all the way up to Canal Street. That storm is the reason this story matters right now, because what scientists who study flood risk are saying, in increasingly blunt language, is that the 1821 event was not a freak occurrence. It was a preview. And the version of it that hits the modern city, the city of 9 million people, the city with the most concentrated infrastructure and wealth on the planet, would not be survivable in the way the 1821 storm was. The researchers who model this have a word for it. They call it doomsday. So let me tell you exactly what they mean, what the data shows, and why the defenses New York is spending tens of billions of dollars to build may already be too small to matter. The threat has a name. Coastal and atmospheric scientists call it the perfect storm, and the term is precise. It refers to a single storm that delivers two extremes at the same time. An extreme coastal storm surge and extreme rainfall. Surge from the ocean, pushing in, rain from the sky, pouring down. Both at once, in one system. That distinction matters more than it sounds, because New York has already lived through each half of that storm separately, and each half, on its own, was a disaster. The city has never been hit by both at full strength simultaneously in the modern era. The 1821 hurricane was the last time the two combined, and the entire warning from the scientific community comes down to one sentence. The combination is not a question of if, it is a question of when. The reason they can say that with such confidence is physics. A warmer atmosphere holds more water vapor. That is not a theory or a projection. It is a basic, measurable property of air. More water vapor in the atmosphere directly raises the potential rainfall rate of any storm that forms. Scientists describe this particular link as essentially certain because it does not depend on a complicated model. It follows directly from the fundamental behavior of gases. Warm the air, and it can carry more water. More water in the sky means more water coming down when a storm wrings it out. At the same time, the ocean is rising. Sea levels along the New York coast are climbing, and every inch of sea level rise raises the baseline that a storm surge builds on top of. Hotter air, more rain. Higher seas, bigger surge. Put those two trends together and you get a storm that does not need to be historically powerful to be historically destructive. It just needs to arrive, and this is the part that scientists emphasize when they are being most direct. The future climate of the New York region is no longer genuinely uncertain in its direction. It will be hotter. It will be wetter. It will be riskier. The researchers studying this describe that as beyond reasonable doubt, and the only real uncertainty left is in the magnitude and the timing, how much and how soon, not in whether the trend is real. Wind risk and surge risk carry a little more uncertainty than the rainfall signal, but they too are projected to climb. So when scientists say the perfect storm is a question of when and not if, they are not being dramatic. They are stating the most defensible reading of the physics. To understand the perfect storm, you have to understand the two storms that showed New York, each half of it. The first was Hurricane Sandy in October of 2012. Sandy is misremembered. Most people think of it as an exceptionally powerful hurricane, and in terms of raw wind speed, it simply was not. By the time Sandy reached the New York region, it had already transitioned into what meteorologists call a post-tropical cyclone. Technically, it was no longer a hurricane at all. What made Sandy catastrophic was not intensity, it was timing and geometry. Several things went wrong at once. Sandy arrived during a spring tide, also called a king tide. The point in the lunar cycle when the sun, the earth, and the moon align and produce a higher than normal tidal range. The water was already running high before the storm added anything. Then Sandy collided with winter weather systems sweeping across the eastern United States. That collision forced the storm into an unusual westward turn, and at the same time caused it to balloon dramatically in physical size. That track placed Sandy on a path nearly perpendicular to the coastline. That perpendicular approach is the key. Because of the counterclockwise rotation of winds around a storm system, a perpendicular track does not push water along the coast. It drives the ocean directly into it. Sandy aimed the Atlantic straight at New York Harbor. The result was the most extreme storm surge in the city's recorded history, a surge of roughly 13 to 14 feet. Hundreds of thousands of people were ordered to evacuate. Seawater poured into the electrical grid and flooded into the subway tunnels, and the failures cascaded outward. Lower Manhattan went dark. A major section of one of the most prominent cities on Earth blacked out, an image people described as surreal. And this is the lesson buried inside Sandy that often gets missed. Sandy was not damaging because it was a monster. It was damaging because of how its pieces lined up. The king tide, the perpendicular track, the westward turn forced by colliding winter systems, the sudden expansion in size, none of those by itself was extraordinary. It was the convergence that made the storm catastrophic. The infrastructure that failed, the grid, the tunnels, the pumps, had been designed for the climate and the storm behavior of the previous century. Sandy was simply behavior that the old design never accounted for. And that is the uncomfortable thread connecting everything in this story. New York's defenses were built for a world that no longer exists. Sandy was the surge. It showed New York exactly how exposed its coastline was, and it was only half of the perfect storm. The second half arrived 9 years later, and it looked nothing like the first. Hurricane Ida made landfall in Louisiana in September of 2021 as a powerful Category 4 hurricane. By the time its remnants reached New York and New England, Ida had largely fallen apart as a tropical system. It barely qualified as a storm anymore. But it was still carrying something dangerous, an enormous load of atmospheric moisture. In New York City, Ida dropped more than 3 inches of rain in a single hour. That was a record-breaking rate, and the number matters because of what the city is built to handle. New York's sewer system is engineered to drain roughly 1.5 inches of rain per hour. Ida delivered more than double that capacity. There was simply nowhere for the water to go. The sewers were overwhelmed, water surged back up into the streets and poured into the subway system, and flooding spread across the city. But here's the part of Ida that should genuinely unsettle you. The most dangerous flooding did not happen at the coast. It happened inland, in neighborhoods, miles from the water, in places where residents had no idea they carried any flood risk at all. Basement apartments filled with water, and in some cases, the people living in those basements died, because nobody had ever told them their street could flood. The flood maps said those neighborhoods were safe. Ida proved the maps were wrong. The danger was not where anyone expected it to be, and that is a vulnerability no seawall can fix. So now look at what New York has actually seen. Sandy showed the city its coastal flank. Ida showed it the rainfall flank. 2 storms, 9 years apart, each delivering exactly 1/2 of the perfect storm. The compound event is not some exotic scenario. It is simply these 2 failures, both of which the city has already lived through, happening together. This is where the story stops being history and becomes a measured projection. The clearest picture of the worst case comes from a flood risk modeling organization called First Street. Their approach uses physics-based models, not guesswork, not simple statistics, but actual physical simulation, to project how the environment around a city will change over the next 30 years and the next 75 years. Crucially, their models account for warming, for sea level rise, and for the flood control infrastructure the city has already installed. First Street ran a specific scenario for New York City. They modeled a 100-year storm surge event hitting at the same time as a 100-year rainfall event. In plain terms, the surge of Sandy and the rainfall of Ida combined into a single storm. The perfect storm simulated. The result is the number at the center of this entire story. Roughly 25% of New York City would flood, a full quarter of the city underwater, and in some areas, the model shows inundation of up to 20 feet of water. Low-lying neighborhoods across every single borough would be submerged. Bridges and roads would be washed out, which turns evacuation from a difficult task into a nearly impossible one. You cannot move millions of people out of a city whose exit routes are underwater. The researchers' assessment of that scenario is not hedged. They state plainly that no infrastructure exists anywhere that is built to handle those extremes, and that in that scenario there would be no safe place anywhere within the city. That is the projection. A quarter of New York gone, 20 feet of water in places, evacuation routes severed and nowhere to go. It is worth pausing on what a number like 25% of a city actually means in human terms. New York is home to roughly 9 million people. A flood that covers a quarter of the city's land area does not just damage property. It severs the systems that hold a metropolis together. Power substations sit in low-lying zones. Hospitals, transit hubs, water treatment facilities, fuel terminals. Many of them are concentrated near the water because that is where cities historically grew. When a quarter of the map goes under, the failures do not stay contained. They chain. The subway floods, so people cannot leave. The roads wash out, so emergency vehicles cannot get in. The grid fails, so the pumps that might clear the water lose power. Each system that goes down takes another with it. That cascading collapse is what the researchers mean when they reach for the word doomsday. Not the water alone, but everything the water breaks on its way through. And remember, the 1821 hurricane already proved this combination is physically possible. The model is not inventing a monster, it is measuring one the city has met before. The difference between 1821 and today is not the storm, it is the city. In 1821, the storm hit a small, low-density town of modest economic value, and the town absorbed it and rebuilt. The same storm today would strike the most concentrated accumulation of people, infrastructure, and wealth on the planet. The hazard has not changed much. The thing standing in its path has changed beyond recognition. There is a statistical anomaly buried in this story, and once you see it, the official language around flooding stops making sense. Both Sandy and Ida were formally classified as 1 in 100 year events. That label is supposed to mean each storm had about a 1% chance of occurring in any given year, a rare event, the kind you might see once in a lifetime. New York saw 2 of them 9 years apart. That is not bad luck. It is a sign that the label itself is broken. The 1 in 100 year terminology is built on the assumption of a stationary climate, a climate that holds steady, where the odds never change. That climate no longer exists. When scientists recalculate those odds using the climate we actually have now, the math shifts dramatically. An event that used to be called a 1 in 100 year flood now occurs, on average, roughly once every 35 years. The return period is compressed by nearly a factor of 3. Think about what that means. There is a popular argument online that 1 in 100 year language is alarmist, that it is manipulated to scare people and justify spending, and that criticism is half right. The label genuinely is misleading. But it is misleading in the opposite direction. It does not exaggerate the danger. It hides it. It makes a flood that now strikes every 35 years sound like it strikes every 100. The terminology is not crying wolf. It is whispering when it should be shouting. And there is a second piece of bad news layered underneath. Air temperatures are rising somewhat faster than the projections expected. Sea levels are rising somewhat faster than expected, which means the official risk numbers, already alarming, are conservative. The real situation is running ahead of the forecast. To be clear, New York is not standing still. The city has mounted one of the largest urban climate resilience efforts of any city in the United States, and the dollar figures are serious. Over the past decade, the city's Department of Environmental Protection has invested roughly $5.5 billion in stormwater protection. Another $10 billion is planned for the next 10 years. That is more than $15 billion aimed at this problem. Much of the coastal defense centers on a project called the Big U. The Big U is a continuous system of seawalls, floodgates, and raised berms designed to wrap around the southern tip of lower Manhattan and shield it from storm surge. Similar protective projects have been proposed for Brooklyn, Queens, Staten Island, and the Bronx. The flagship piece of the Big U is the reconstruction of East River Park. The city has poured roughly $1.5 billion into raising that entire park by 10 feet, physically converting a public park into a flood barrier. That single project is designed to shield more than 100,000 low-income residents, people in a neighborhood that had historically been passed over for infrastructure spending. But surge is only half the problem, and the city knows it. Roughly 70% of New York City's land area is covered by impervious surface, concrete, asphalt, rooftop. Rain that hits those surfaces does not soak in. It runs off, fast, in enormous volumes, straight toward a sewer system that maxes out at 1.5 inches per hour. So the city has also begun building green infrastructure, rain gardens, porous pavement, parks, redesigned to hold stormwater like sponges. The goal is to make the urban surface absorb water instead of shedding it, and to divert some of that runoff away from the overloaded sewers. After Sandy, the city also installed floodgates at subway entrances and built out a network of pumps to clear water that does get into the tunnels. This is real work. It is serious money. And every study on the subject agrees on one thing. $1 spent on adaptation before a disaster is more efficient than $1 spent on recovery afterward. The investment is not wasted. The problem is something else entirely. Here is the problem. The defenses are scaled to the wrong storm. Look closely at the Big U. It is engineered to protect against a storm surge of a magnitude lower than the 13 to 14-foot surge that Sandy actually produced. Read that again. The city is building a wall sized for a storm smaller than one it has already survived. Sandy is not a hypothetical for New York. It happened. The water came in at 13 to 14 feet, and the flagship coastal defense is being built for less than that. Now look at the scale. As proposed, the Big U will cover roughly 10 miles of coastline. New York City's total coastline is approximately 520 miles. The Big U protects under 2% of the city's edge. Extending that level of protection around the rest of New York would carry a price tag so large it is difficult to even discuss seriously. And then there is time. Every piece of this infrastructure is being designed for the flood risk that exists right now, but the risk does not stay still. By 2080, the threat from both extreme rainfall and storm surge is projected to be substantially higher than it is today. The city is building defenses calibrated to the present, and they will be obsolete before they are finished because the target keeps moving. This is what the title of this video means. The worst flood threat to New York City is escalating faster than the city can build. The risk curve is rising, the construction timeline is slow, and the gap between them is widening, not closing. That is the race, and right now the city is losing it. There is one more piece of physics that makes this worse, and it is the most quietly alarming part of the entire story. You might assume the danger only increases when storms get stronger. It does not. Because sea level rise raises the baseline water level, future storms do not need to be more intense than Sandy, or more intense than the 1821 hurricane, to cause worse flooding. They just need to arrive on top of a higher ocean. A storm identical to Sandy, same surge, same track, same strength, hitting New York decades from now would produce a worse flood than Sandy did, for one simple reason. It would start from a higher starting point. That means the threat escalates passively. It grows on its own. Even in a calm year, a year with no major storm at all, New York's flood risk goes up because the sea keeps rising underneath the city. The danger does not wait for a hurricane. It accumulates silently every single year, whether anything happens or not. This is why a growing number of planners are arguing for a fundamental shift in thinking. The old goal was to keep all the water out. That goal they now concede is impossible. The new approach is what some call learning to live with water, designing parts of the city to flood safely on purpose. Streets engineered to function as temporary canals, parks built to act as reservoirs that fill during a storm and drain afterward. High-resolution rainfall radar deployed as a minutes-ahead warning system, because in a flash flood, a few minutes of warning is the difference between evacuating a basement and dying in one. The goal is no longer to prevent the flood. It is to control where the water goes, and to buy the minutes that save lives. New York is the focus of this story, but it is not the only city in the crosshairs. The same compound flood logic, surge and rain together on a rising sea, applies up and down the eastern seaboard. And the frontier of highest coastal flood risk in the United States is on the move. Right now, that frontier sits in Florida, but it is migrating north toward New Jersey, New York, Long Island, Rhode Island, Connecticut, and Massachusetts. The entire northeast corridor is moving into the risk zone that Florida currently occupies. New York's perfect storm problem is a preview of a regional reckoning. So here is where this leaves us. The perfect storm is not science fiction. It is not a distant model output. It is a precedented event. The city of New York has been hit by it before. Aim now at a target that has become vastly more vulnerable, more populated, and more valuable than it was 2 centuries ago. The modeling shows the outcome. A quarter of the city underwater, 20 feet of water in places, evacuation routes severed, no safe ground. The city is spending more than $15 billion to outrun that outcome, and the defenses, as currently built, are sized for storms New York has already matched or beaten. The honest bottom line is this: nobody can tell you the date. The perfect storm could be decades away, or it could form next hurricane season. What the science can tell you with real confidence is the direction. The risk is rising. It is rising faster than the projections assumed, and faster than the seawalls are going up. Whether the next great storm becomes a manageable emergency or a genuine catastrophe is not yet fixed. It still depends on what gets built, how fast and how big. That is the part worth watching, and it is the part still in human hands.